All right, in just the next few minutes, we're going to tackle everything you need to know for your GCSE AQA Geography Paper 1. We're going to break down all those complex topics into simple, clear ideas that will help you absolutely ace your exam. So let's get right into it. So think about this for a second. What on earth could an earthquake in Nepal, a rainforest in Indonesia, and a river in the UK possibly have in common? I mean, they seem like they're from totally different worlds, right? But believe it or not, they're all part of the same incredible story of our planet. And by the end of this, you'll see exactly how they link up. Okay, so here's our game plan, and it follows the exam paper perfectly. We'll kick off with natural hazards, then we'll explore the living world, and we'll wrap things up with physical landscapes right here in the UK.
Right, let's dive into our first section, the challenge of natural hazards. We're talking about the awesome, powerful forces that can literally move the ground right under our feet. First things first, what actually is a natural hazard? See, it's not just a big storm or an earthquake on its own. A natural event only becomes a hazard when it threatens us, when it's a danger to human life and our stuff. The key word here is threat. So what's making these massive tectonic plates move in the first place? Well, it all starts deep, deep inside the Earth. The core's crazy hot temperatures heat up the rock in the mantle, making it rise, kind of like hot air does. When it gets closer to the surface, it cools down and sinks again. This creates this constant circular motion, these powerful currents that are like a giant conveyor belt, just dragging the plates along for the ride. Now, the real action, the drama, it all happens at the boundaries where these plates meet. At a destructive boundary, you've got two plates crashing into each other, and the heavier one gets forced underneath. We call that subducting. That creates a ton of friction, leading to volcanoes and earthquakes. Then you have a constructive boundary, where plates are pulling apart and magma bubbles up to create new land. And finally, at a conservative boundary, they're just sliding past each other. The trouble is, they get stuck, pressure builds and builds, until, bam, it's released in a massive jolt, an earthquake. Okay, so theory is one thing, but let's see how this stuff plays out in the real world. We're going to put two major earthquakes head-to-head and compare their impacts, one in a low-income country and one in a high-income country. So, in one corner, we've got the 2015 earthquake in Nepal, which is a lower-income country. And in the other, the 2011 Tohoku earthquake in Japan, a high-income country. First up, let's talk about sheer power. The earthquake in Nepal clocked in at a very strong 7.8 on the magnitude scale. But the earthquake in Japan? It was way, way more powerful, a staggering 9.0, one of the strongest ever recorded. So you'd automatically think the damage in Japan would be far, far worse. But that's not the whole story. And this is where we see the massive difference. Japan, being a high-income country, had an unbelievably fast response. I mean, check this out. Major roads were rebuilt in just 6 days. Incredible. But in Nepal, a lower-income country, they really struggled. Landslides blocked roads, making it super hard for aid to get through, and the whole nation had to rely heavily on international help. It just goes to show you, a country's wealth and preparedness are absolutely critical for coping with a disaster. Okay, let's switch from hazards under our feet to the ones up in the sky. How do you actually make a tropical storm? Well, think of it like a recipe. First, you need a really warm ocean. We're talking at least 27 degrees Celsius. This heats the air right above it, making it rise super fast. As that air rises, the Earth's rotation, which we call the Coriolis effect, starts its spinning. The storm picks up more and more speed, and then cool air sinks down in the middle, creating that famously calm eye. The whole thing only runs out of steam once it hits land and loses its fuel, that warm ocean water. So, we've seen the powerful forces that shape our planet. Now, let's explore the incredible life that calls it home. Welcome to our second section, the living world. And get ready for this, because this fact is just mind-blowing. Tropical rainforests cover a tiny 2% of the Earth's surface. Just 2%. But they are home to over half of all the world's plant and animal species. That incredible biodiversity makes them so important to the health of our entire planet. But, and it's a big but, these vital places are under threat. And if we look at our case study of Indonesia, the cause is pretty clear. It's overwhelmingly human activity. You've got logging for wood, clearing massive areas for farming, and huge mining operations. They're the main things driving all this destruction. You know, life in the rainforest has adapted in some seriously clever ways to survive there. To stop from rotting and all that dampness, leaves have developed these drip tips that let heavy rain run right off.
Down on the dark forest floor, there's a huge race for sunlight, so vines called lianas literally climb up trees to reach the top. And then you have animals like the orangutan, which have evolved these incredibly long, strong arms, perfect for a life spent swinging through the treetops. Okay, for our final section, we're zooming right back home to the UK to look at its physical landscapes. We're going to see how the nonstop action of waves and rivers carves out all the country's unique features. You can think of every coast as a kind of battlefield, constantly being shaped by waves. And there are two main types. You've got your constructive waves, which have a really strong swash. That's the water washing up the beach. It's stronger than the water going back out, so it deposits sand and actually builds up the beach. Destructive waves are the exact opposite. Their backwash, the water dragging back out to sea, is way stronger, so it eats away at the coast and carries sand away. It's a constant tug of war. Now, this whole process of erosion creates some truly amazing landscapes. So waves smash against the coast and they wear away the soft rock much faster than the hard rock. This leaves a piece of hard rock jutting out into the sea, called a headland. The waves then focus all their energy right there, turning little cracks into caves, and then those caves get battered until they become an arch. Eventually, the top of the arch collapses, leaving a pillar of rock all on its own. We call that a stack, like the famous Old Harry Rocks down in Dorset. So how do we actually protect our coasts from all this? Well, we've basically got two main choices. There's hard engineering, which means using big man-made structures like seawalls. They work, but they're really expensive. The other option is soft engineering, which tries to work with nature. It uses methods like beach nourishment, which is really just adding more sand to a beach. It's usually cheaper and looks more natural, but it often has to be maintained. Just like coasts, rivers are incredible sculptors of the land. Way up in the steep upper course, the river has a ton of energy, so it erodes downwards, carving out steep V-shaped valleys. Then, in the flatter middle course, it doesn't have as much power to cut down, so it starts eroding sideways, creating these big sweeping bends called meanders. And finally, in the really flat lower course, the river slows right down and just drops all the sediment it's been carrying, building up wide, flat floodplains. One of the absolute coolest features a river creates has to be an oxbow lake. So here's how it happens. On a meander, the water flows fastest around the outside bend, which erodes the bank and makes the loop even bigger. Over time, the neck of the meander gets skinnier and skinnier. Then, one day, usually during a flood, the river decides to take a shortcut and just smashes straight through the neck. The old meander gets blocked off by sediment, leaving behind this beautiful crescent-shaped lake. But sometimes, these natural systems get pushed way, way past their limits. The 2004 Boscastle flood is a perfect and terrifying example. Just listen to this number. 1,400 million liters of water fell in just 2 hours. To even try and get your head around that, that's basically a whole month's worth of rain getting dumped in a single afternoon. It created an absolutely devastating flash flood. So, we've journeyed from the center of the Earth to the rainforest canopy, all the way to the UK coastline. And that brings us right back to our first question. How is all of this connected? Well, I'll leave you with this last thought. A single volcanic eruption in Indonesia can chuck so much ash into the atmosphere that it can actually change the weather patterns here in the UK. Knowing that, what does that tell us about how we should manage this one shared planet we all live on?